Hello everyone, welcome to our ecological succession notes. I'm Miss Heim. You may remember me from other science videos. I'm excited to be here today to teach you all about succession. So let's get started. I'm going to be using multiple colors to fill in these notes. If you don't have colors with you today, that's totally fine. Just use a pencil or a pen. Those of you who like to use the exact same colors as I do, I'm going to show you the colors I'm using. Feel free to grab these colors. If you don't have these colors, again, not a big deal. Those are the colors I'm using. So now that we've taken care of that, let's get started. Ecological succession. We're going to start with the definition, and our definition is the process of an ecosystem gradually regrowing over time. So the process of an ecosystem gradually regrowing over time. So, what does this definition mean? Well, hopefully you remember from way back when that an ecosystem is an area of land with biotic and abiotic factors. So we learned about different biomes before all this craziness, and each biome is unique based off of the abiotic and biotic factors. So for example, a grassland is a much different ecosystem than a forest, right? Those are both ecosystems, but they're both unique. With succession, we start off with an ecosystem, but something affected it, something changed it, and it has to regrow. So ecological succession is how an ecosystem gradually regrows over time. As we're doing these notes today, we're going to have two examples. We have one up here. This will be primary succession, starting on bare rock, regrowing the ecosystem. And then secondary succession will be starting with soil and regrowing the ecosystem. So we're going to do these examples or causes last. We're going to jump into primary succession first. For primary succession, we're going to write primary succession. So primary succession is unique because it's succession in an area with no soil. And I'm going to write no soil in all caps to really emphasize that fact. So succession in an area with no soil. So basically the ecosystem is regrowing, but it's regrowing from nothing, from just bare rock. Here is our little timeline. We are going to fill in information on each of these pieces. So with primary succession, as I said, it starts with bare rock. So I'm going to take my gray and just kind of shade in my rocks to remind myself that, oh yes, these are rocks. And I'm going to label that this is bare rock. With a little air going up. And I'm going to remind myself that because this is bare rock, there is no soil. All we have is bare rock, some sunlight, and then I'm assuming there'd be some water at some point, right? Right? Rainfall, all that good stuff. But that's how primary succession starts. Area with no soil. You might be asking, how do areas with no soil exist, or where would that exist? A couple different ways. A glacier could have went through this area and scraped all of the soil off of the bare rock. So all that's left is just bare rock. Or a volcanic eruption could have occurred, covered the whole area with molten lava, the lava hardened and formed just bare rock. So those are some ways that could happen. On the next phase, so we're looking at many years later, we still have our bare rock. So I'm going to shade in with gray. But as you've probably noticed, there are some little dots on here. And these little dots are lichen. So I'm going to shade those in with green. Now lichen are very simple plants. They're similar to mosses. You probably have seen lichen in your neighborhood. It grows on trees. grows on soil, grows on rock. It's pretty simple. Like it doesn't need a lot. It just needs some sunlight for photosynthesis and some water. So I'm going to shade in my sun there. Okay, so we have our lichen. Let's fill that in. These green things are our lichen, as I said, which is like a type of moss. And our lichen are our first species. I'm going to remind myself of that. And we're going to fill in one more piece of information. Because our lichen is our first species, the vocab word we're going to use to describe that is pioneer species. Pioneer species. Now, in succession, we'll say the word pioneer species to describe the first species to go or to regrow in an ecosystem. I think about it as, the pioneers who settled the West. They were the first people to move to, or first American, or first colonizers to go, to travel west and to go to to settle new areas of land. So we think about like pioneers being the first settlers. Pioneer species are just the first species that regrow. Okay, so this takes, does take a little bit while to get the lichen or the pioneer species to get to the bare rock. You might be asking yourself, well, how does lichen get there? Lichen can travel over by human activity. So if humans are in that area, they could have accidentally carried it over, dropped it off. By the wind can carry the lichen over. Water can carry lichen over. Animals or plants, if they're, not plants, excuse me, but animals like birds could fly over and drop lichen. It happens, but it doesn't happen intentionally. Okay, after more years, we still have some bare rock, so I'm going to shade in the rock. And as you can see, we still have some lichen, so I'm going to shade in the lichen. But you may notice it's not just rocks and lichen anymore. We have some small grasses. So I'm going to take that same green and color in the grasses. And what that means is if we've got some small grasses growing, that must mean that there is some soil. So I'm going to take my brown and just do a thin layer of soil right underneath those grasses. So after many, many years, the lichen are going to start chemically breaking down the rock surface. There's acid in the lichen that break apart the rock surface. The rock surface also gets weathered from rain and wind, that also helps break it down. So the small rock pieces combined with the lichen that are living and dying and then decomposing, so like the decomposing lichen, will start to form the first layer of soil on this bare rock. So that, again, takes a long time. Let's color in the sun and then we'll fill in our information. Okay, and then over more time, more and more soil starts to form. And with more soil, oh my goodness, sorry. Sure, why not? With more soil means it can support more plant life. So here we have some taller grasses. And of course, we still have our sunlight. Okay. In this case, we are going to call this our climax community. Oh, I do this every time. I always run out of space. Okay, I'm going to write community down here. So climax community. This climax community is a grassland. For this ecosystem can support a grassland. That makes it, it's sustainable for a grassland. So the amount of precipitation in this ecosystem, the temperature range, allows tall grasses to grow, maybe some small shrubs, but that's as large as this climax community is going to get. This is a sustainable environment for this ecosystem. When the grasses start to regrow, small insects will start to come back. When small insects start to come back, then small mammals will start to come back, and then larger mammals can come back after that. But it takes the regrowth of these lichen and small grasses and tall grasses to make this climax community sustainable. And this is about as large as this community will get. So that's why we call it climax community, because it's the ultimate stage of this community. It's not going to grow any larger. Climax communities will be different for each ecosystem. Okay, that is primary succession. Succession in an area with no soil. So we started off with bare rock, lichen, where the pioneer species to come in. Through chemical weathering, the lichen start breaking apart the rock to form a thin layer of soil. Once soil is there, small weeds and small grasses can start to grow in. And then once those weeds and small grasses are there, insects will come in and continue to develop that soil. Once the soil is fertile and healthy, larger grasses can grow in, small shrubs, small mammals, all that fun stuff, until that ecosystem reaches its final stage, its climax community. And it'll continue to grow in that stage until another disruption. Okay, moving on to secondary succession. Secondary succession is our next type. And this is succession in an area with soil after a disturbance to the land. Succession in an area with soil after, I'm going to underline with soil, after a disturbance to the land. So key difference here is with soil, right? We're not starting on bare rock. We are starting with soil. In secondary succession, we can actually see here that we have the original ecosystem. So I'm going to start by shading that in. We have a forest ecosystem here. We've got our tree trunks. Sorry, I'm doing this very poorly. I'm just going to kind of quickly shade these in. I don't want you to have to stare at me coloring for a while. But here's our forest ecosystem. However, we have a catastrophic event that comes in and interrupts this ecosystem. So the catastrophic event in this case is a wildfire. I'm just going to take some yellows and oranges, kind of color that in. Fire. Okay, and I'm going to label this catastrophic event. Now, catastrophic events can also cause primary succession. We just don't have it illustrated, but in this case, wow, catastrophic event of a wildfire. So, was a forest, catastrophic event, came in, disrupted this land, and all that's left is soil. Now, the soil is filled with ash, right, from the burnt plants, but it's still there. So it has some burnt pieces in it. I'll do some darker spots to represent the ash. But the soil is still there. So I'm going to write soil is present. Soil is present. Okay, so we're starting off with soil. The soil is already there. It doesn't have to be broken down. It's actually been fertilized by the fire from all the ash from the burnt plants. So our pioneer species in this case are going to be weeds, grasses, small shrubs. These are all our first species, and we're able to regrow weeds, grasses, and small shrubs first because there's already soil present, and that soil is fertilized, as I've said. There's nutrients in that soil to start to regrow the grasses and small shrubs. It doesn't have to be broken down from rock because it's already soil. So where lichen or our first species in primary succession, weeds, grasses, and small shrubs are our first species in secondary. So I'm going to write pioneer species down here to remind us that those will be our pioneer species because they can grow in that soil. Okay, Once our weeds, grasses, and small shrubs start to regrow, we're going to see insects returning. And then once insects return, small mammals can return. And that whole process is going to go through, it's going to take a few years, right, to keep that ecosystem regrowing until it grows back to what it previously looked like. So it's going to grow back to the forest ecosystem that it started off as. Got some trees. I'm gonna do these ones in darker green. And then I've got, I don't know, I guess that was my lighter green. I'll do these ones in the darker green. Okay. So we've got our forest, we have our grasses, we still have soil, obviously, that didn't go anywhere. And voila, we have our climax community for this forest ecosystem. So as I said before, not all climax communities are the same, right? Based off of the ecosystem, based off of the biome, the climax communities are going to be different. So this one did have to regrow from soil into a forest. This one regrew from, because that's secondary succession, right? Soil, grow into a forest. If it started off as, let's say if it was the African savanna and it was like a grassland and there was a forest, there was a fire in the savanna, it would regrow to a grassland, right? It just depends on what's sustainable for that ecosystem. So we're going to add one thing up here, and we're going to add the word sustainable. So I'm writing the word sustainable ecosystem. A climax community is a sustainable ecosystem. That means that there are enough biotic and abiotic factors to keep all the organisms living there healthy. There's enough food sources, there's enough water, there's enough space to keep those organisms alive, or to keep that ecosystem healthy. So a climax community is sustainable. Okay, that's to recap for secondary. It does start with soil is present. A catastrophic event comes in, disrupts an ecosystem, leaves soil. That soil then is able to support pioneer species as weeds, grasses, and small shrubs. Those continue to grow. Insects, small mammals return, and the ecosystem keeps on growing until it reaches its climax community, where it is sustainable to support life in that ecosystem. Okay, there we go. We're going to go over these causes of succession next, and these are just examples. Let's write the word examples of different things that could cause succession. Our first one is going to be gardening. So this is just a bag of potting soil. I'm going to shade it in brown, kind of color in some parts with green. So I'm going to do that, and then I'm going to write the word gardening off to the side. And then we'll talk about if it starts primary or secondary succession in just a second. Next up, we have our volcano. So shade it in your volcano, give it some lava. And I'll write the word volcano. And then last but not least, we have a hurricane. So I'm just going to shade in my coastline. This is clearly the United States. There's Florida. We're already getting information on predictions for our hurricane season this year. It's always interesting. And that's our hurricane right there. Okay, so potting soil with gardening. So what that means is, let's say I left my backyard unattended all winter, and now we're getting into spring, right? So most of the spring, and it's regrown. It's crazy. There's weeds out there. There's shrubs that appeared somehow, or there's tall grasses. It's just kind of a mess. If I go into my garden and I start pulling those weeds, I dig out the small shrubs, I mow down the grass, and I just kind of leave it down. Maybe I remove some of the grass. I just leave it bare soil. I've made my plot of land for my garden. Just soil, removed all that junk. Now, Let's say I change my mind. I just abandon it again. I abandoned it all summer. It's going to start regrowing, right? So what we're going to think about is my failed attempt at gardening. Would that result in primary or secondary succession? If I pulled out all those weeds and grasses and then I just left it alone again, what type of succession is it going to go through? Okay. Well, the answer is it's going to go through secondary succession, right? Because if I left it alone, I left the soil there, so it'll just regrow from the soil back to the state that it was before. Okay, volcano. Let's say the volcano erupts, covers everything in the surrounding area with molten ash or molten lava and ash. That molten lava hardens to form rock, and then that ecosystem will have to regrow, right? Would that volcano result in primary succession or secondary succession? The answer is primary succession. When that lava hardens, it's going to form rock. So the ecosystem will have to regrow from bare rocks. That makes it primary. And then last but not least, secondary, what we've got? We've got a hurricane. Our hurricane, let's say this hurricane goes through Galveston. It's knocked down trees. It's moved small shrubs. It's disrupted our ecosystem, that ecosystem down there in Galveston. As Galveston's regrowing, will it go through primary succession or secondary succession? The answer is secondary. The hurricane might move around some soil, but it's not going to remove all the soil and bring it down to bare rock. It's going to leave some soil there, and it might be moved around, but it's not stripping it all the way down to bare rock, so it will be secondary. Okay, one last thing. When you downloaded these notes on the back, there's a little timeline like this. I'm going to fill that in real quick with you with these examples of catastrophic events. So we're going to use gardening, volcanoes, and hurricanes, and we're going to determine the time in years for each of those. So let's start off with the one that would take the longest amount of time. Of these three, try to predict which one you think would take the longest amount of time to regrow the ecosystem. Gardening, volcanoes, or hurricanes? Okay, the answer will be volcano. And that is because it is primary succession. Primary succession takes a long time because it starts with what? It starts with bare rock. So that bare rock has to be broken down. That could take that could take almost half the time on its own. Breaking that rock down to form soil. Then once there's soil, then the soil has to be enriched. It has to get fertile. It has to be able to support small grasses and weeds and shrubs before that climax community can be reached. So again, we start with bare rock. The light can get there, help break down the rock to form soil, and then the soil can then support weeds, grasses, and small shrubs. So it takes a long, long time. In this case, it looks like it's around 100 years. Let's jump to the one that'll take the shortest amount of time. So between gardening and hurricane, which one do you think would take the shortest amount of time for the ecosystem to regrow? The one that'll take the shortest is gardening. And that is secondary succession. So with gardening, I left the soil there, so weeds will start to regrow, and then small grasses and maybe small shrubs. It might take less than 20 years for my garden to regrow. That could maybe even take 6 months. But let's say if there were trees in that area, the trees would take longer to regrow back, right? If it was more of a forest type ecosystem that I removed for gardening. But either way, it's not going to take as long as a hurricane it's not going to take as long as it would for an ecosystem to recover from a hurricane. So hurricane, there's going to be more damage, more widespread destruction. So it is still secondary, but due to the large scales of hurricanes, it has a much greater impact on an ecosystem rather than just a small plot of land for gardening. And that whole ecosystem to recover will take a much longer time. So here it's looking like around 60 years. Again, it depends on what the original ecosystem looked like. Okay. You guys have been awesome. Thanks for hanging in there with me as we went through this. I hope you're having a great day. Ask your teacher if you have any questions. Great job. See you later.